Alright guys, welcome back. We are GAME3001, that's Game AI, in the winter 2020 semester at George Brown, and we're week 7, part 1 of our broadcast. We're going to be talking about A-star pathfinding with some heuristics. And for today, what we're going to do is we're going to use a project that we were using before from last week. We're basing it off of our GAME3001 repo. So I have a project that I made, 7D. It's based off of 6D. Okay, 6D was the last week's project, right? So this is the project that I want to use. I do want to update the GitHub repo right now, so I'm going to make one live. So I'm going to go to GitHub, and I'm going to go to, if I do the proper thing, which is go to George Brown. Haha. And here I'm going to make a new repo, just like last time. So GAME3001 in the winter 2020 semester, and it's lesson 7D, which gives me a nice two last lines of code, which I'm going to, I've already prepared for this. So I'm just going to drag and drop this stuff into my command line so we can set up a project. Okay, that should push us up to our code, so that's where we're going to start. There we go. So if I look up online now, we can see that here we're using this repo. Okay, we're just continuing from this repo. This is just called 7D for today. All right, so last time when we left off, we were able to create a grid for ourselves. So if you look at the grid, and I'm just pulling up the first thing I'm going to do when I pull up my solution is just try and pull it up. I'm just waiting for this my Visual Studio to configure with ReSharper C++. Takes an extra moment. I know some people have been reporting that it slows their system down a little bit. If it's slowing you down, guys, don't use ReSharper. Use something that makes sense for you, right? Me personally, it doesn't really bug me if I have to wait a minute so that my tools get ready, but for you, if it bugs you or if you find it's too slow, turn it off or uninstall it. It's for our use, right? So I'm just running this thing and see what we got. That's the one thing I want to do because it's going to help us troubleshoot everything else. All right, so we have a little ship. We press 1, and when we press 1, we get this grid. And yeah, I mean, sure, we got these big numbers here, but these big numbers don't make any sense. They're actually numbers that are pixel from this position. There's going to be a kind of a distance, if you will, in pixels from this direction to this direction. That doesn't really help us. I want to use grid position. That's what I want to use instead. All right, my grid position. Are you guys with me? So you should have this right now. Yes? No? Anybody? All right. Yeah, so this is the problem, right? Well, we don't want this, right? We want to be able to calculate the distance in grid space, in tiles, from here to here. And we're going to use two heuristics. One of them is going to be Euclidean distance, and the other one is going to be using Manhattan distance. And we can define those two heuristics. All right, so where do we do that? So if I go to my Solution Explorer, inside of my placing.cpp, I created we kind of built a grid, right? And if you look inside of our start, then we do this. We build our grid, we generate our planet, spawn our planet, and spawn our ship. Whenever we spawn our planet, this thing, our spawn planet thing itself, go to definition, what it does is it calls the calculate tile values function. Calculate tile values function goes through every tile and takes a look at the position, and it sets the target distance for each of the tiles. So if I go to set target distance, this is in the tile itself. For each tile, what it's going to do is it's going to say, okay, well, let's get the tile value from the distance between the goal location and the position in world space. Well, we don't want the position in world space. What we want is the position in grid space. So there's actually another function that the tile has. So if I go to this definition, here's the definition. So here inside the tile class, here's the tile class, right? In the tile class, we also have, oh, this is the object class. Sorry, let's go back to the tile class. That's what I meant to do. So I want to go back to the tile class. So let's go to definition for the tile. Here's the tile. And the tile is a display object, but you notice that there is also a get grid position. So this gets the position on the grid. That's what we want to use, not get position. So again, if I go back, I want to use get grid position here. So get grid position. And this gives us like our position on the grid. We don't need to scale it anymore. That was something that we did just temporarily, right? And this actually finds the Euclidean distance. So that's what this does. So it says that, use Euclidean distance, right? Heuristic. And you know what? Tile value is good, but we've broken it down into just tile value. And maybe what we should do before we set the tile value itself, what we'll do is we'll do what we should be doing, which is the Euclidean heuristic is going to be set to h. So we'll call this float h. And remember how it works. We have our tile value, so m underscore tile value, and that's going to equal to the tile cost, right, multiplied by h. So we're going to say multiply g by h. That's what we want. The tile value is multiply g by h. Well, g then is just the config tile cost, right? That's what that is. So that's the tile cost, which is now 1 by default. So there's g and h. So this is g plus h. So my tile value is g plus h. So this is the distance, and this gives my total value, and we set it to the tiles. And when the tile value is set, this is what we're going to show on each tile. Okay. Cool. So next step, what we need to do is we need to make sure that when we pass in our goal location, it's not the location of the planet in world space, but actually the planet in grid space. So when I go back to the calling function, which is in my placing.cpp, which is right here, instead of saying the planet position, we don't want this. We want to set the planet's get tile, get grid position, which is going to be the one that we want. We want the grid position of the tile that the planet's sitting on. That's what we want, as opposed to the planet's world position. Okay, now that we've done this, and if I press play, we should see different numbers than what we saw before. And let's take a look. And this is using the Euclidean distance. Okay, so again, it's a diagonal that goes from one of the tiles to the other. You can see that from the ship now to the planet, you can see that there's different tile values, right? And this does a diagonal kind of distance from here to here. Now remember what we talked about in lab today, or in lecture. We said in the lecture that whenever we do this, that we should probably have access to the corner tiles if we're going to use Euclidean distance, but we don't. And we're going to get sometimes into a position where if I was going to follow these tiles for a second, and I follow them up, so I said, okay, I want to follow it to the closest tile now. Let's say I'm going to go here to 9.1. I can't go diagonal. That's not our game. We go here to 9.1. Okay, from here, I can go 8.6 or 8.2. I'm going to go 8.2. We're going to go 7.7 or 7.4. I'm going to go 7.4. 6.8 is 6.7. And then when we get to this tile right here, oh man, we have this tie that we're going to get into. So we can go either direction, either this way or this way, and it should be the same values both ways. Why? Because we're exactly on the diagonal. That's when this thing happens. And we can't go diagonal. If we can go diagonal, we would have saved ourselves some trouble and just go right there, but we can't do that. We only know about 4 tiles, our neighbors. Okay, that's what we want to do. So that's one way of doing it. We can use, this is Euclidean distance, right? That's what the tiles are calculating here. Let's try and show you Manhattan distance. And if you remember, our lecture today had Manhattan distance. we talked about this, where we had H, which is a heuristic described as the absolute value of the current cell on the x-axis minus the goal cell on the x-axis, plus the absolute value of the current cell on the y-axis minus the goal cell on the y-axis, and that gives us our heuristic for Manhattan distance. It kind of gives us this thing that looks like an L. All right, let's code with that one now and see what the difference is. So go to definition. And this is the distance formula. We're using the Euclidean. Let's comment this out. And now let's make it so that we can use Manhattan distance. So Manhattan distance uses that other heuristic, right? Again, we're going to say that float h is equal to the absolute value of the current position, get grid position dot x, and minus the goal location, which is our goal dot x, okay? And we're going to add the absolute value of the, just going to put this over here so we can line it up nicely so we can see it. The y's to get a different heuristic, a different number. That's what we're looking for here. This is going to be counting tiles as opposed to getting distance as the crow flies. Okay, so this is what this does, and this would be the Manhattan distance. Okay, heuristic. There it is. And let's see how this works. So again, if I press play, it's going to still calculate the costs. But now the numbers are different. You notice the numbers are, there's no 0.1s or anything else like that. It's all, regular values. Why? Because we're counting tiles. We're saying, okay, so how many tiles away is this tile? Well, it says 13 tiles somehow. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 1 for the tile cost, right? Which is a total of 13. Okay? That's how it works. And also, one thing we're not doing is we're not adding up the total accumulated cost for all the tiles. We're not doing that. We're not saying like, let's add up recursively how much it costs for each of the tiles to be added in. We're not doing that. We're not saying like for each tile in the list, as an example, calculate what the difference is between where we are and where we're going. We're not doing that. We're just saying, okay, what's the cost for this particular tile, for the target distance from each tile, right? That's what we're doing here. Okay, so we're setting the target distance for each one, and what we're not doing is we're adding the tile cost. So what this is returning, right, is it's just calculating the distance, as an example, for according to the goal location. And notice in my placing, what's happening is for each tile, we're setting the target distance for each tile, right? We're adding it up and we're setting it up together, okay? So this is great, but one thing we want to do is we want to think about how we're going to start mapping tiles. Each tile doesn't know about the other tile. If we're going to start doing pathfinding, what we need to do is think about our tiles like this. Imagine if I can use Excel here for a second. I have a grid of tiles that kind of go from the left to the right. This is our grid that we've kind of defined, right? Now, this is not to scale, but I mean, we can fit it all on one page, which is what I've done here. So now, as we notice, these are the columns on the top, and these are the rows on the left, right? And what we want to do is we want to saying, okay, well, if I have a tile here, let's say this is a tile T, here's our tile T. I want to know about this tile, the up tile. I want to know about this tile. I want to know the one below it, right? I want to know the one left of it, and right, and the one on the right. I want to know these ones. Okay? Does this make sense? I want to know about these tiles. I have to make linkages. This tile should point to these 3 tiles or these 4 tiles. They should know them. And this is definitely one case. So the way I would do this is I would count the grid and I would say, well, you know what? If on the grid this was x is equal to 9 and y is equal to 3, let's suppose that is the grid location. We'll say, so location for this one is x is equal to 9, right? and y is equal to 3, right? So on the grid, that's what it looks like. That's the location. That's where t is. So then what would this be? Well, obviously, we're going to count backwards on the y. So it's going to be up would be like whatever x is, and then y minus 1, okay? And then down would be whatever x is and y plus 1. So obviously then x would be 9, right, for up. And then y would be 2. And then x would be 9 and y would be 4, right? And it makes sense. There it is, right here. And you can see the same thing with left and right. So left, well, y would be the same, right? So y would be 3 for both of those. But then x would be minus 1, so 8 for on the left, and then plus 1, which would be 10 on the right. And this is great for a tile that's in here, this one case. But what about a tile that's not there? For example, if I try and map tiles that are somewhere else, like maybe in the corner here. What if t was here? Then, well then, you know what? I can't do y minus 1. That would be a problem. That would be a case where I would have an issue. I would also have an issue with t being here, 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 anywhere here, or anywhere here, or anywhere here. Those are all the cases that are special, maybe even this one here. And again, I'm just anything along the borders basically is where I'm going to have problems. And I'm just going to mark these borders as anything that goes there, we're going to have issues. We'll just mark it with a lighter kind of a gray color. So you guys can see that, maybe. Okay, so that's kind of what we want to avoid. We want to avoid all these t's, right? These ones here. Well, we can't. We have to, there's got to be something in this area here, right? These things have to have, you know, kind of a, you know, tiles. The tiles are going to be there, and we have to map them. So all we care about, we don't care about the tile that's off screen. There's no tile there. We care about this tile and this tile, these two tiles. But we want to mark the other ones as null pointer somehow. That's what we want to do. So we're going to do kind of a tile mapping. And I want to make it so that there is a, once we build our tile up, or build our tile grid, which is going back to here, we do inside of the start method. We go to start, you can see that we build our grid, right? Well, what I want to do after we build our grid is map tiles. I want to map all of our tiles. So let's do that in our placing.h. Let's go placing.h for a second. Here it is. In placing.h, what I want to do is after we build our grid, we want to map our tiles. So we're going to do a tile mapping out thing. So map tiles. You can also say connect tiles. I used connect tiles in the previous class. I'm just going to generate that implementation. There it is. Okay, so I want to map my tiles, and I need to go through the grid to do this. I'm going to say we're going to do a for each loop. Again, there's many ways to do this. You could use also a nested for loop if you feel that that's better. But I'm going to do a for each loop, and I'm going to say that for every tile in the grid, what I want to do is I want to do that mapping exercise, right? But how do I map things? Is there some mechanism that the tiles have for mapping? Well, the answer is yes, there is. And if I go to my tile.h, you can see that I have something called a neighbors vector. The neighbors vector is a vector of type tile pointer. That's what it is. That keeps track of all of the neighbors around my my tiles, okay? And I also have some convenience functions. I have set up, set down, set right, set left, where I set the tile. And I have up, down, right, and left, where I get the tile. Let's take a look at these ones first. I'm going to go to definition for these ones. In my up, I say that, hey, I return the neighbor that is up. Up is 0, and then down is 2. What I've done here is I've used a clockwise method where I've set up a numerator. Right? Let me just get rid of these qualifiers for a second. Okay, I don't need them. I've set up some kind of enum, and if I look at the enum right here, way at the top, where up is 0, right, down, and left. So I go kind of in a clockwise direction, where up is the first one, then I go to the right, then I go down, and then I go to the left. And that's how I'm mapping out my tiles. 0, 1, 2, 3, right? And so when I'm here, when I set up, then I set the 0th thing, but I can't, set it unless it's actually been set. And one thing I'm missing here is inside of my tile constructor, what I should do somewhere is set my neighbors to null pointer. So I can do something like this. I can say that m_neighbors, I can set it to null pointer. So I can kind of set up a bunch of null pointers just to confirm that they're all null pointer at the end. So I'm setting 4 variables, or sort of 4 values, 4 pointers. They're all null pointer. So they're pointing nowhere. It's kind of, I'm initializing my my neighbor's vector like this. Okay? And what this does is it guarantees that there's going to be some kind of element that I'm creating for them. I'm creating it, the element, but I'm also making it null pointer, so I can test for it. And now that I've done this, what I can do is when I set my tiles, so let's go to the set up, set down, all that stuff. So here's set up. You can see that before I was just pushing back. That's not going to work. Pushing back is going to push it in a random place, or the last position. And depending on my order that I do this, that may mess me up. What I want is to specifically set the one that I want. So I'm going to comment these ones out instead. And now that I've set up them as null pointers, there are positions that we can do this. And I'm just going to get rid of the qualifier again. So this is what it should look like now. Again, I'm inside my tile CPP class file, and I'm just getting rid of the qualifier that's next to my neighbors. When I set up my setup, set down, set all these setters, and I'm just going to get rid of this. I'm not going to need this anymore, just from a cleanup perspective, really quickly. So what I'm going to say is basically when I call this set functions for my tiles, I'm just going to set that particular element inside of the vector. And again, I'm treating this like kind of like an array. I could probably use an array here as opposed to a vector. It doesn't really matter for now. Okay? Are you with me? Because what I'm doing here is basically I'm able to set each of the tiles, right, in clockwise order. So up, right, down, and left. That's what I'm doing. Okay, cool. Now that I've done this, then I know that in my placing, when I map my tiles, for each tile, I want to set up the right, for the top, right, bottom, and left. So I can do that. I can say that for each tile, set up to a particular tile, right? And we're going to talk about this in a second. So how do I do this? So how do I set my up tile? Well, going back to my Excel file, what I want to do is I want to get the tile that is above me, as an example, on the grid. So I need to get my location, my current location on the grid first. I need to get the X and Y locations for me first, okay? So where that tile is. So again, in the beginning, what I wanted to, I'm going to say that, let's go float X, and I want to get my grid position. That's equal to, I'll do that in here. In my for loop, float X is equal to tile get grid position dot X, and float Y is equal to tile get grid position dot Y. So I got X and Y coordinates for my tile. And what I want to do is I want to set the up tile. I want to set the grid, right? Whatever the tile is on the grid, m_p grid. And I want to take, and I only have a one-dimensional grid, and I got to think about this. I want to take the position here. If I want to find this position on the grid, it's not 9 and 3. There is no multi-dimensional grid. It literally is, a bunch of rows here and columns, right? So I want to count 19, and then plus another 10. That's 29. So this is 9, 29, 39, 49. That's what it would be. We count 20 every time, which means we're going to multiply the y by 20 in order for us to march down the grid. Okay, so here what we want to say is, we want to say that y multiplied by 20, but we want to use 20 because 20 is just our tile size, or how many tiles we have. What we want instead is we want to use column. So we're going to say config, and notice that we have column number, right? Column number tells us that that's the count, and maybe we're doing this because in the future you're going to maybe have a different column size, right? So that's where we're accommodating for this. So that's in the y-axis, and then we're going to add x-axis. So we're going to say, well, remember, because we're going to say, okay, so this is where we are on the y-axis. So we're say, you know, example, if we were here, it would be 0, and then this would be plus 20. So this is 20, this is 40, this is 60, this is 80. So we're here 80, and then we add 9 as an example. This would be like 89. Okay, as a good example, right? And so we add x at the end. So we can add x in the beginning. We say x plus whatever this is going to be the position of our x and y coordinates on the grid. So instead of using multi-dimensional array, we're just using a single-dimensional array, but we're using x and y to find where we are in the array. Okay, so we're saying, hey, go to this particular tile. That is our current tile. Okay, but now that's our current tile. We want to set the up tile. And the up tile, if you notice, is whatever the current tile on the y-axis minus 1. So we're going to say y minus 1. And we're going to multiply that value, whatever that is, multiply by the column config. Right? And that is the up value. Okay. And let's do that for the rest of them. So I'm going to copy and paste. So this is, we're going to do to the right. And maybe we'll do down first. So up and down. So if y minus 1 is for up, then y plus 1 is for down. Okay. And for right, we'll do right and left. Then we don't care about, we want to keep y for right and left. But now we're going to add or subtract 1 from x. So again, if we notice when it's going to the right, we add 1. So add 1 to x. We'll say x plus 1. And here we're going to say x minus 1. Okay, so that's our grid. It looks pretty messy. Let's make it so that it looks nice. So again, I'm just going to, you can have as much white space here as you want for this stuff. I'm just going to space it so that it is just spaced so we can see things a little bit easier for our eyes, so we can visualize this. We don't have to do it this way. I'm just doing it for us. I'm also going to line up the x's and the pluses so you can see what this looks like, right? Okay? Does that make sense? So if you look at this, what we're doing is we're aligning everything so that when we set the up tile, we're just going to count minus 1 on the y-axis. When we set the down tile, it's plus 1 on the y-axis, just like we've done. Actually, let me just space these out too, just to make it, it's just for completeness. There we go. And again, we can make as much white space as we want here to do this. But what we were doing here is we're just mapping this out, and we're trying to say what it is. But we have problems, right? We have a problem. For example, remember that gray area around the tile? We have to accommodate for all those areas. So if we're at the top, that means that when y is 0, right? We don't want to count the top tile. We don't want to go higher up. We want to leave it as null pointer. So the only time that we want to set the up tile is when y is not 0. So again, we're going to say if y is not equal to 0, then what I want to do, I'm just going to wrap these in little curlies here. Take this whole line here, and wrap it in those curly braces. So I'm going to say something like, if y is not 0, then that's the only time that I want to set up the tile. Okay, cool. How about the down tile? Well, that's when y, if y is not equal to the column, the height of my screen, right, or my column height, my row, number of rows that I have, so config row number, so we're not at the 15, right, minus 1. If that's not what it is, then just like we've done before, then we can set down, all right? If that makes sense. Because if we were to do this otherwise, I'm just going to space this out again so that they're aligned with each other, so you can see what this looks like again, okay? Because I think this is important to get right. Okay? Hopefully it didn't mess anything else up. There we go. Okay, so that is if y is not equal to 0, and this is if y is not equal to the row number, right? So row number means like 15 minus 1, 14. If it's not here or here, we're okay. Okay? Similarly for the other ones, we can say that if x, so this is for the right, if x is not equal to the config column number minus 1, that means it's not like at the edge of the thing, then let's make some curlies and let's put this inside here. This is the only time we want to set it, when it's not that, right? If it happens to be that, that would be a bad circumstance, because then we're going to try and set something that's null pointer that doesn't exist, you know, and that would be bad. We're going to leave it as null pointer. We're not going to try and set it, you know, something that doesn't exist. And the same thing goes with the left. If x is not equal to 0, then that's okay. That's when we want to set the left to the other condition there, and we want to move this over. Okay, so that kind of sets up our tile mapping. And I'm just trying to keep this so it's kind of organized and clean, and so that you guys can see what you can see. So you can see what this looks like. All right? And that, my friends, does the tile mapping. And I've kind of put them on one line. I know that's kind of a little contra to what I normally do, but it kind of keeps everything succinct and to the point. You can see how it goes. And I'm using this up, down, right, left. Let's make it so that it is in order. So it's up, right, down, left. So I'm just going to move the down away from this just to be, you know, organized. Undo. I meant for it to go in the right place. Wow. Somehow I really messed up. Okay. I love Visual Studio, but it bugs me when it does that. All I'm doing is trying to organize here. Up. So cut. And then we'll just make some spaces. Right. Down. Left. That's what I wanted to do. And let's just organize this so it looks nice now. Again, you can see that this has been a little bit maladjusted, which is totally fine. I want to move this to the right here so that it looks nice. Okay, good. There it is. So that is how it goes. So up, right, down, and left. That's our clockwise order of setting up our grid. Okay? And that does the grid mapping. Now, we don't know if it worked. We don't know if this is going to work or if it's going to crash our machine. Let's see what happens by running it. So again, I'm going to run this thing. And does it crash? The first thing I say is, hey, does it crash? Is it running? If it doesn't run, that would be a bad circumstance if we can't do our grid mapping. Okay? And we're doing this, why? Because, oh, this is kind of, we have to reorganize that. We're doing it because I want to be able to kind of map out all the neighbor tiles so we know what the values are. Okay? And again, you can see that if I move my stuff around, it does generate some noise. Take a look at that. I am still getting quite a bit of a memory leak on here, which we'll fix at another time. I'm not going to fix the memory leaks right now, but you can see there's something going on where I'm leaking memory all over the place. Okay? All right, cool. So let's just fix some of this formatting. You know what? Maybe it's okay. I wanted just to align stuff so that it looks the same. I'm kind of cool with this. I'm fine with this the way it is. So it does the mapping, but let's do one more thing. I want to create a breakpoint. Maybe we'll do is we'll do an auto, as an example, we'll say temp, and we'll call it my grid, right? So we'll say that we'll make a grid. And what I want to do is I want to show the grid somehow. So I'm going to do this just for a thing. This is a debug. So debug point, right? I'm just doing this so I can set up a breakpoint in a second. There's many ways to do this, but this is the way I like to do it. So here, I want to set a breakpoint here. So when I come and do this thing in the mapping, I want to see what my final grid looks like. Okay? This is for each tile now. So I'm going to run this thing, and let's see what happens when I finally set up my grid. Okay? So I guess I'm going to press 1, and then it's going to take me to this, and yeah, that's not what I wanted. Yeah. Oh yeah, it would be nice if we actually called the tile mapping thing. Haha, we never called it, that's why it's not coming here. Map tiles, we need to call that in the start. Let's go to start, and after build grid, that's why it worked. M_P, map tiles. So we build the grid and map the tiles. Let's see if it crashes now. So again, 1. Okay, so it takes me to my debug point. Let's see what my grid looks like. I want to start inspecting my grid, and the way to do this, I do this on purpose to set this up. If I actually hover over my grid, you can see that I'm getting all the grid tiles. These are all the grid tiles from 1 to 300. All right, I can see them come up here. This is a good way of doing it. I go into the first grid tile. You can see that I want to go into my neighbors, and this is what I'm getting. I'm getting my 0 neighbor. My top neighbor is 0 or null. I'm getting some neighbors on the right and the bottom, but my left neighbor is also null, which is exactly what I want. I want this mapping, which means that on the top left corner, I have 2 nulls, right on the top and one on the left, which is exactly what I'm looking for. Okay, how about my 19th tile, which is the one towards the right side of the screen. 19, which is the 20th tile. Let's look in there. You can see again in my neighbors, when I look in there, I can see that my top and my right are both null, but my bottom and my left have a value, which is totally cool. So I know how to do that. I'm good. My tile mapping is working, guys, and I'm not getting an error. So let's stop this. I've mapped my tiles, and let's get rid of these 2 things. That was just our temporary things, just to see if we can inspect everything. And what I'm going to do here is I'm going to put this up on GitHub now. So I'm going to go to my Team Explorer, changes. I'm going to say added tile mapping, or neighbor. It's really neighbor mapping. Map tiles function. Okay, so commit all, and I'm going to go home, sync, and push, which is going to push those changes up on GitHub. Okay, so that's what this map tiles function does. It actually maps all the neighbors. All right, so now that I can map all the neighbors, now I'm in a position where I know each of their costs. I know each of the neighbor tiles. So right around me, I can detect what each neighbor's tile costs. And now that I have that I know all the neighbor costs, I can start calculating what the lowest cost is. Okay, so I want to make a convenience function for this, where I can calculate the lowest cost of the neighbor tile that I'm looking at. And this is going to be the first part of my pathfinding, right? So I want to be able to say this. I want to say, okay, given that I have neighbors, again, going back to my Excel, right? Let's suppose that this is my start, and here, this is my goal, right? What is my heuristic from here to here? This is my start point. I'm just going to start mapping this stuff out. And let's just get rid of these T's. I'll keep the gray area there because we know that's going to cause us some trouble, especially when my planet is on the edges. That might cause us some issue. That might be an edge case, actually. But let's see what happens here. So what I want to do is this. I want to say that let's start mapping out what the costs are really quickly. And what I want to do is just do some Euclidean distance calculations here. So if this is my start, what does this tile give us? Well, let's count it. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 for the tile, where this is going to be cost 9. Okay? This one. 1, 2, 3, 4, 5, 6, 7. Plus 1 for the tile, 8. And you get the picture. 7, 6, 5, 4, 3 is probably what it's going to cost, right? Let's try this out. So again, it's 1, 2, 3, 4, 5, 6, 7, 8, plus 1, 9. So this one is from here, it'd be 1, 2, plus 1 is 3. This should actually be 3. So what did I mess up? 9, 8, 7, 6. So counting from here. Oh no, this is 1 less. So it's 8, 7, 6. Because I'm counting from the start, and I shouldn't be. 4, 3, 2. That's how I should look. All right, so if this is the case here, what about the other way? So if I go 1, 2, 3, 4, 5, 6, 7, 8, right? So same thing, right? So this would be 8. Because look, it's like from here, it's 1, 2, 3, 4, 5, 6, 7. Plus 1, 8. Right? Right? 1, 2, 3, 4, 5, 6, 7. And this would be here. This would be 7. This would be 6. Oops. This would be 6, 5, 4, 3, 2. So these are the exact same. What happens in a situation like this? And what about this tile? This one is 1, 2, 3, 4, 5, 6 plus 1 is 7. So this is a 7, right? This one here. 1, 2, 3, 4, 5 plus 1 is 6, and then 5, and then 4, and then 3. Okay, so that's the numbers that we have around our goal. Does that make sense? So this, I'm just showing you what it looks like if I want to find from my start to my goal which path I would take. What about these ones out here? We probably should map the ones around me too, right? So I can say that, what about this one? This would be kind of like 9 because it went away. This is 9. You can see this now, right? This one probably would be 10. And this one would be 10. Right? And this one would probably be 11. Okay, so this is what it looks around us, right? And so if we're starting here, we can go either down or left. Or sorry, down or right. So how do I determine a tie? How do I fix this tie? So Megan, what do you think? How do I determine a tie? If I have these numbers and I can go, I'm at the start, and I have to choose whether I'm going to go down or to the right. How do I choose that? What was that? Good. But I could also do something like this. I could also just cycle through my list, right? I can go, okay, check the top tile. Is that the minimum one? No. Okay, check the right tile. Is that the minimum one? No. Check the bottom tile, and so on. And the first minimum tile that I find, for example, this one, would be the tile that I'm going to start moving in. So I'm going to start moving in this direction. So I could use something called counterclockwise first. So whatever I find, the minimum tile in the counterclockwise direction, I'm going to go in that direction. Now, there's other ways of doing it. You can use right-hand rule, where you always try and find out to the right, what's to the right of the facing. So if this is going this way, the facing would be kind of in this direction. And what's to the right of the facing, I can use the dot product to find this tile. And that would be the right-hand rule. I can go this way, right? But in our case, it doesn't matter because both this tile and this tile are equidistant in terms of how many steps we have to take, because this is exactly a square, right? It's kind of a rectangle, right? So it's the same distance from one way or the other. So we don't care. We want to use the right-hand rule to figure this out, okay? Or, sorry, the clockwise rule. We're going to start at the top, and then we're going to kind of cycle around until we find the minimum value. So what we want to find is we want to find the minimum tile value, and we're going to use a little convenience function to find that from our neighbors. So we need to have our access to our neighbors somehow. Okay, so let's do that. So in my placing.h, I want to find the minimum tile value, right? So I want to do, and this is going to be happening like after I do everything else. So I'm going to compute the tile values, and then what I want to find, this is my first pathfinding functions, right? So my pathfinding function, these are just like building up my grid and setting it up. These are all tiling grid functions, right? But here, this is pathfinding stuff. All right, so I'm going to say that I'm going to return the tile, right, that I find. So I'm going to say m underscore find tile with the lowest cost. So we'll say lowest cost tile. We'll make a big name here. Again, I did it differently for the previous folks. And the only way I can do that is if I pass a reference to a vector of tiles that I'm looking at, some kind of vector of tiles, right? So I'm going to pass in a vector of tiles. It's going to be looking like this. So standard vector of type tile pointer, right? We're going to call this neighbors. Okay. Let's define this one. Here it is. So again, find lowest cost tile, calling it neighbors. And what we want to do is we want to get the neighbor, we want to get out of it, whatever the neighbor is, right? I'm going to say that I'm going to loop through for each neighbor, for each tile in neighbors. So for, use that range for loop again, right? So again, for each, haptic, for each tile, for each tile in the neighbors vector, for we'll say for every tile in the neighbors vector, for every tile, what we want to do is we want to loop through each of them and then check to see which one is the lowest tile. So I got to set some kind of minimum value. I got to have two things in order for me to do this. First of all, I got to return the minimum tile. So I'm going to have a minimum tile. So I'm going to say that tile pointer, we'll call it min tile, right? We'll set that to null pointer at the beginning, okay? And we're going to return that out. That's what it's going to return. Okay, so we're going to return this somehow. We're going to find the minimum tile and return it out, right? But we're also going to do some marking. We're not just going to find the lowest cost tile. We're going to also mark the other tiles around it for now. Okay. Cool. What I also want to do here is have a minimum number. So we're going to start off with some kind of floating point number that's going to be min. And we're going to set a value of that floating point number. We're going to start off at some arbitrary value that's pretty high, like 1,000. I mean, we don't have a very big grid. You can make it so it's positive infinity if you really want to, where positive infinity is the first cost, some large value, right? And again, you can look up how to do that. You can literally just call infinity. So if I say something like infinity, right? Then as long as you have the math function defined, this is like some huge number. You must have, if I'm not wrong, math somewhere defined in order for you to do that, right? But that's what it starts off at, okay? So if my minimum tile is infinity, right, I want to check that the minimum file, if it's greater than the tile that I'm looking at, then swap the value of the tile with the minimum tile. So I'm going to say if min is greater than the tile cost, and would be, right? So get tile value, right? If this is true, then I want to do two things. I'm going to set the min to the tile value. So I'm going to set the min to the tile value, right? And then I want to set the min tile, this minimum tile, as the lowest tile. So I'm going to say min tile is equal to tile. Okay? So that kind of selects the lowest tile, right? And so what this will do is if I go back to here, it starts off and it goes, okay, so let's start here. So in order, I want to come to the first one. Is this one the lowest tile? Well, it's less than infinity, so we'll take this one. So the lowest tile, let's just run through this exercise. Min becomes 10. Okay, so that's the lowest tile. Yay. Then I go to this one. Is 10 greater than 8? Well, yes it is. So then min becomes 8. Okay, is 8 greater than 8? No. Min stays 8, and that's the lowest tile so far. Okay, is 8 greater than 10? No. So keep min as this tile. This is the first tile. Notice we said it's going to be in clockwise selection order. So it's going to select this as the lowest tile. So this is the next position that it's going to go in. Okay? But what if, what if this was not the case? And what if, I mark this one as the lowest tile, but then I want to unmark it and mark this one as the lowest tile. So if this was already marked as the lowest tile, I want to unmark it. I don't want to make that the min tile anymore, right? And the one that I marked lowest, I want to call that the open tile. So what I want to do is I want to say that, hey, min tile dot, actually I can use tile or min tile. It doesn't really matter. Min tile, I'm just keeping track of which one it is, but I can say that, hey, tile, the tile that I've marked as the lowest tile, that one, I want to set tile state. I want to set that to open. That's the one I want to go to, right? If this is the minimum tile. However, if it's not the minimum tile, right? Somehow I'm already smaller, right? For example, in the cases where I'm already 8, this is not the minimum tile. I want to close this one off. This is not going to be an open path for me. So I want to say that the tile set tile state then is closed. But there are cases here when this would be bad to do. For example, okay, so I march along, and then I'm here, and well, I was here, so do I make this closed? So the answer is, yeah, I don't want to close this off if it's already S or open. I don't want to close it off. So here we'd have to make a check for that to happen. I'm going to say that, well, if the current tile, whatever the current tile is, tile, and we'll say that it is get tile state, right, is not equal to, if it's not already open, then it's okay. Make it closed if it's not already open. In fact, the only time this should happen at all is when you have an undefined tile. Only if the tile is undefined, so not visited basically, that's when you're going to make it closed. Okay? That's the only time you want to make the tile closed. Not if it's something else already. If it's something else already, if it's a start tile, if it's an open tile, or if it's a goal tile, you don't want to make it undefined. You want to leave it alone. Okay? So that's something that we're setting up. This is just the first iteration that we're trying to figure out. Okay? Cool. But what about in this case? What about if I mark this tile as min, right? I already marked it as open, but I don't want the top to be open anymore. I'm trying to still find the minimum tile, right? So I get to check to see if the minimum tile is already been made. So I'm going to say that, well, if min tile is not equal to null pointer, so if it's already been, we've already used it for something, then I want to set this one to closed, right? If it's not null pointer, I want to set that one to closed. So I want to say that min tile, we have to use tile or min tile because we don't want to get rid of the other one right yet, the other reference. Min tile set tile state to close. But there's also a provisor for this. What if, as an example, the previous tile, we want to set it to open as an example, but maybe the previous tile was, as a good example, was some other kind of special tile, right? So that's going to maybe mess us up. But for now, let's just do it this way and see what happens. So that's the only time we want to set it to closed. When we're passing through it, we're saying, okay, we selected that, but that's not the one we want. Okay? So let's see if this little thing works. This basically will go through the tile. It'll set up the minimum tile as a null pointer. And then we're going to start with a minimum as infinity. And what we're going to do is we're going to work our way down to the tile values until we have a tile value that we're going to select. That will be the minimum tile. That's what we're using this min for. Min is really going to be our control variable select the minimum tile value. Okay? In fact, we can probably use a tile comparator if we wanted to here, but I'm not going to do that. Okay, so cool. We return back to this min tile, and we return back from the calling function. We don't have a calling function right now, so let's see if we can call this function somewhere. I want to call this function right now when I press the F key. So I want to go down to my control grid here. And when I press the F key, I want to call this m underscore find lowest cost tile. And I'm going to pass in the first place I want to look, which is going to be my ship. So, or sorry, yeah, yes. So I'm going to say find the lowest cost tile around my ship. So it's going to be like m underscore p ship. And I want to pass in the get tile, right? But I need the neighbor. I need to find the neighbors from that tile somehow. I want to find the neighbors from that tile, right? And there is no get neighbors. I can't get the neighbors from the tile because it doesn't do that. It just gets the grid position. I can get right, left, and all that stuff, each individual one, but I don't want to get each individual one. I want to get them all. So the way to do that is to change my tile.h so we can get neighbors. Remember, neighbors is here. I want to just get another a getter to do that. So I'm going to put it down here for now and say it's going to return a, again, we may have to do this differently later, but for now, I'm just troubleshooting. I'm just creating our structure, and then we can refactor again. A vector of tile pointer, right? As an example, we're going to call this get neighbors, right? And we're going to define this thing. Get neighbors. We're going to return m underscore neighbors, all right? A reference, right? We're going to return a reference to neighbors, and it says, hey, maybe you want to make this const. I don't care about that right now. Okay, so that's what this is going to do. So going back to here then, I'm going to say, okay, ship, get the tile, and from the tile, get its neighbors. So get neighbors, and return that back out into my find lowest cost tile. Okay? Yeah? And I also want to generate this on my, when I press my I am GUI button. So there is a bunch of buttons I have here. I'm just going to go back to the button, which I'm going to be here, and we'll say, you know, find shortest path. And here, we're not really finding the shortest path. We just have a convenience function that we're testing right now, which is this. Let's see if we can get the lowest neighbor, the first lowest neighbor, okay? All right, and let's run this thing and then see if it works. So if we run it, and if everything goes well, then this is the next thing we've done for ourselves for this structure. All right, press 1, and you can see that we've got our grid. Here's our grid. I want to find the tile that's the closest one, that's the lowest one, right? So I'm going to press F for this, and you can see that it found this one, 0. Why did it find this one? Well, because if you notice it, we marked them as these are closed, and this is open. And what it's doing is saying, well, this one down here is the lowest cost. Well, so is this one. It doesn't matter which one it chose. It chose the one on the clockwise direction. If I move my ship again, oh man, that's an artifact. I got to clean that up. When I move my ship, remove my planet, I got to reset everything back to undefined, right? But if I press it again, you can see that it still finds the bottom one. Let's move my ship again. How about this? In this case, if I press F, well, it finds the top one because it starts at the top, right? So that's the first place. It marks the other ones as closed. Keep this one open, and then I can make my way this way, right? Let's keep going. I'll move it around until we find something that we can find. There, how about this one? That's pretty simple. It finds the closest one, the one that's the closest. So this is working, right? But now we have to clean this up. So whenever I move my ship or my planet, I need to redefine or reset all my grids, my grid tiles. So let's do that first, and then we'll put it up on GitHub. So again, I want a convenience function for this. Something like, reset grid, void m underscore reset grid. Okay, so I'm going to just make this one. Reset grid is going to go through each of the tiles in the grid and reset them to undefined. So I'm going to say, which is unvisited really at the end of the day. Right, so for each, again, I'm going to use the grid. I'm going to use auto. I'm going to use tile. I'm going to say for each tile in the grid, then go through it and then set tile state to undefined. Okay, that's what I want. So it's going to reset it every time I call reset grid. And I'm going to call reset grid every time I move stuff. And that happens on spawn object. Every time the object is spawned, before I do anything, I want to reset the grid. I'm going to say that m underscore reset grid. Okay, this is going to set it up. Okay. And let's try this out. Now this is going to cause us to have an extra memory leak because I'm doing this every single time I move. I'm changing everything, resetting everything back to the way this is, and that might cause a little bit of memory leak, more than we have. So again, here we are. You can see that it rushes to about 70 megabytes, pretty big now, big memory leak. And if I press P to move, you can see that it jumps up to 80-ish. If I keep moving the planet, you can see it keeps jumping a little bit at a time. So there's a bit of a memory leak going on there, just a bit. Same thing with my move my ship. It also does the same thing because I'm resetting all those factors everywhere I want. However, now if I press F and if I move it, it disappears. F, you can see it disappears. Wherever I go, it starts generating the locations. Well, that's interesting. Now what happens there? So it flags this as open, and it shouldn't. If this is a goal tile, it shouldn't flag it at all as open. So if it's a goal tile or if it's somewhere else that's specific, you can't flag it as open. It's got to be set to goal, right? So that is a bug. So again, if I go back to my my map tiles works, but I want to be able to find lowest cost tile. So again, let's go through this. It says, okay, hey, I'm going to set this as open, but what if that is already the goal tile? Well, I don't want to set that as open. That would be a bad situation. So I want to say something like if, and the only way I can do this is if it's not, I only want to change anything if it's undefined, right? If it's closed, I don't want to open it up again. So for now I'm going to say if my tile, actually we have an example of it here. If this is undefined, only if it's undefined, right? Then I want to set it to open. Okay? If that makes sense. So only if this is undefined, I'm going to set it to open. Otherwise, I'm going to keep it with what it is. Let's try that again. Let's see if that messes me up, right? Because again, we want to use this as our state to do it. So I'm going to again press this one button, and we're going to get our state happening. I'm going to press F, and you can see that that is pretty cool. We found our first one. And if I move it around, and if I press F again, you can see that that calculates that. That is, there's two, but it's going to calculate, it's going to use the clockwise rule that we made to calculate that one. Move it around again, press F. You can see it chooses one of these two. It's equidistant here. You can see so it doesn't really matter, right? Same thing here, right? In order for us to calculate the next tile. All right, so we've done this one, which is find lowest cost tile. This is a great place to put it up on GitHub. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. And I'm going to say that we added find lowest cost tile method, or function. We'll call it function. There it is. And we're going to go commit all, home, sync, and push. And that's going to push everything up to GitHub. So we have that update as well. Cool. Nice. Excellente. So now we need to go to the next part. So I want to use my find lowest cost tile, but I want to be able to pathfind with this thing. This is our first step to pathfinding. We're not using any kind of lists right now. We're just like literally just going off the, running with it just in real time. This is not the solution. This is just one part of it, but we're just doing this so that way we can start doing some simple pathfinding using our whatever we pass in here as neighbors. Okay? So let's make another convenience function. We'll call this pathfind. So again, here, this is our first find. And we'll say, and we're not going to use recursion. We could use recursion here, but we're not going to do that. We're going to say it's going to return void, and we're going to just pathfind. Or actually, let's call it find shortest path. Find shortest path. Okay? Find shortest path is going to start with the start, and it's going to find our way all the way to the end. All right, so let's go to generate implementation. There it is. And what we're going to say is we're going to use our find shortest tile, this one. And let me just go and grab that thing we already did, which is inside of our, here, this one. We're not going to do this anymore. I'm going to cut this out and just put in m underscore find shortest path. That's what I want to do there. And same thing goes with the IMGUI stuff now. Okay. But in my find shortest path, I want to do this. And that's going to be my initial tile. My initial tile is going to start off where my ship is. So that's going to be my initial tile. We'll call this just simply tile. Tile is equal to this, right? So my tile is going to be this. I can also use auto here. That's going to be my initial tile. That's where it's going to start, okay? And again, just to test this function without any bad stuff happening, we're just going to eventually when it builds, we're going to come here and press 1, which is going to basically define our grid. And if I press F, it's going to find the shortest path, the shortest tile. These are equivalent, which works nicely, so that's okay. But I want to loop through it. I want to say that, okay, fine, now that I have the initial tile, that's my first tile, right? I want to take that tile and I want to find the shortest path from that tile. And I want to keep doing that until, I want to keep looping until I have I found my goal. So you can use a do while, right? That looks kind of like this, right? So do this until my tile, right? And again, we got to set this up here like this a little bit. So say tile, that's going to start equal, we're going to make that equal to null pointer in the beginning. And we're going to say that while my tile, which is the get tile state, while it's not equal to goal, right? If it's not equal to the goal, so that's where we want to get to, right? Keep going. Keep doing this while it's not equal to goal. Now, one thing we should check while we're going through this, because this could be an endless loop, right, is there some way of knowing that it's the goal? So again, we set the path. The path can only be set to open if it's undefined, right? And what we're going to do is either way, we're going to return the minimum tile, right, when we've gone through this loop. For every tile we're going to go through, then we're going to return the minimum tile, right? And we should probably return the minimum tile if it's equal to, if tile is equal to goal, we should just break out and return that minimum tile, whatever that is, right? So we'll say if, let's copy this. If tile is equal to goal, because we want to search for this, then we want to return right away min tile. Anytime that it's going to happen, once we get the goal, even if we did it like with any of the iterations, right? We want to get out of here and do this, right? In fact, if we think about this, we can do this before we check if it's the min, right? So if we set the new tile, and we're looking at the neighbors around that tile, if that's the minimum, if that's the goal, whatever that's going to be, well, then that's the one we want to break out. All right, so we look through each of them, right, and we're saying that if any one of those tiles, right, for every tile and neighbor, if that neighbor tile is the goal, we want to return that tile out. Okay, we want to do that first thing. So we're going to say take this. You don't have to even be in here to find the minimum. We can test it right away. So if any time this tile is equal to goal, then we want to return tile. Okay, that's the one we want. Okay, let's see if that works now. So going back to this. So again, we've got our null pointer, we've got this, and then we've got this condition that's going to break us out, we're hoping. When it's not equal to goal, it's going to break us out. It's going to be equal to goal. Tile will be equal to goal when we break out. That's what's going to happen, right? And then we'll break out of this loop. Okay, hopefully that works. Or we'll get a infinite loop, one of the two. All right, so let's try this out. So we're going to go to this, and we're going to do find. And now you can see that we're getting an infinite loop, right? Somewhere, we keep on going, and it's climbing forever. And this is where our logic we have to test. This is where we left off with the last group. All right, so what's happening? When is this going to happen? When it's as long do while this is not equal to goal, right? Okay. Well, yeah, of course it's going to be forever because this is going to be the initial. We need some initial state, and what's happening is it's always going to point to the ship, so that ship is never going to be equal to the tile. So what we need to do is pass in the tile here is what we want. So in fact, we can set this part here, right? So we set the initial tile to the ship. And then we say is, okay, cool, that's okay. Tile is equal to, let's pass in the tile for the ship. And let's iterate through each of the tiles, right? From the one that we return. So we're returning a tile, whatever that new tile is, right? We're going to check that one out, whatever the new tile is. We're going to keep doing this over and over again. Let's see if that helps. Okay, and let's try it. And then press F, and we're going to get that endless loop, right, happening. Because we have to find our base state, base case. So again, this does it at least once. That's what do while does, all right? That's what do while does. So again, let's go through it. So tile comes in here, and it says, okay, cool, tile is equal to this. We're passing in tile out here, right? And what we can do is, to make this easier, is we can have something like initial tile where we come in. And let's check how this works. So logic-wise, again, what we want to do is we want to pass in the initial ship. The ship tile is the initial tile we're gonna use, right? So ship tile. And if we were to comment this out just for a second, so let's just comment out the loop part, so we can understand how this works. Here's comment this out. If we just did this, right? This part, we say tile is equal to this. Okay, that's not going to hurt anybody to do this, right? What does this do? Does it even do what we're supposed to do? So the first part without the loop. Then we'll check out each of the tiles and each iteration. All right, so cool. We could do this, and we press F, and then OK. So it says exception thrown. M tile state, get tile state was thrown. Y. Let's look at the call stack. It says find lowest cost line 108. That's when it was called, 108. And then find shortest path is 147. So 147 and 108. All right, so let's go back to this. 147. Well, yeah, so it says take the tile, right? And we want to make a reference to the ship, right? Here it is. And if you just comment this out for a second, just for 1 sec, okay? So can we even do this? Like, this is the stuff I always check, like one thing at a time. I mean, this is totally doable, of course. And you can make this so that it is auto, right? Because we know that that's going to be a tile. It's going to be a class tile. That's what getTile does, right? Class tile. And let's see if that even works. So then I'm going to run it. And then press F, right? So every time I press F, doesn't matter because nothing's happening, but we're not getting any memory leaks and we're not moving forever. If I press M or P for that matter, we're good to go. It's not, we got a little bit of memory leak, but nothing crazy. So this is okay to do, right? Again, this is a tile pointer of tile. So this is. Okay, and now what I want to do is I want to call the shortest path. So I want to do something like this. I want to just using this stuff, I'm going to say M underscore find shortest path, and then it's going to be tile, and then get neighbors. Can I do that? And it says, well, no, function has 0 parameters, but it's being called 1 of shortest path. Find lowest cost tile. What I want to do. Okay, cool. So that's what I want. And let's see if that works. So one at a time. Of course, that's going to work, but let's test it. We're going to just try and troubleshoot what the problem is. So find, see that first iteration works. Okay, cool. So we got our tile. So after we do this, we got our new tile. So lowest tile. So this is the initial tile. Let's call this initial tile. So the initial tile is the ship. Here's the initial tile. Initial tile. Right? Sure. And what I want to do is auto tile is equal to this. Right? And let's see if that works, because that's kind of what I did already, right? So tile is equal to this, and I press F. You can see that it finds it, no problem, right? Move it, find it, no problem. That all works still. So this totally is okay. So I've got this kind of idea. This is the idea that I want. But I want that this is the tile. This tile is going to be this, right? And it's going to store it in this new variable, right? This variable here. Can I do this without crashing? This part. So I'm saying, well, okay, cool. This tile, I'm going to pass it in here, and this is going to come out here at the other end. Can I do this kind of work? Right? And then let's see what happens. This is kind of what we did down here. And again, going back, pressing 1. Press F, and we're good. Right? We're good. Moving, press F, good. All right, so it stores it inside this. It stores tile in here, all right? And if I was going to find what this tile is when I press F, because F basically does this. It goes here, sets up the tile, passes it over, passes it back, right? And I want to find the transition between this, get neighbors, right? And this, which is the actual tile itself, right? So whatever that neighbor is. So let's make it so that there's two separate things. We'll say that auto neighbors is equal to tile get neighbors. So again, breaking it down for us to find the problem. right? There it is. And we'll pass in neighbors in here now. Neighbors. If I can type properly. I cannot type at all. In any way. There we go. It's kind of a weird word, neighbors. All right, so yeah, I want to see that this is cool. So I get the neighbors, I pass the neighbors in here, and that's cool. Then I get my tile back, right? And this is kind of what I want, right? This tile is going to be something that I want to update every frame. So I'm going to get my new neighbors, and then whatever neighbor is going to be on my tile. And then what's going to happen is I'm going to pass neighbors in there, and then tile is going to be, there's going to be a new tile is going to happen, and this is going to keep looping until tile is equal to something else. Let's do this a couple of steps. We'll loop it only a few steps. We'll say make a regular for loop. Oops. We'll say for I, we'll do it, I don't know, 5 deep, something like that. So we'll say that the upper limit is 5. All right? So we're not going to loop forever. We're going to loop in a limited amount, and we're going to see how far this goes. So we're going to say that this is the case. We'll comment this out, make it all messy, right? And we'll say, okay, so yeah, it says typo in neighbors. No, it's not. Add const. I guess I could, because basically what's going to happen is then it's going to generate the neighbors. It's going to pass it in. It's not going to modify anything. It's going to return back this tile out again. And we're going to run this 5 times. So it's going to go through 5 iterations. All right. Now sometimes it might overshoot because we're not searching for stuff, but let's see what happens. So run. All right, so we'll press 1. And we'll press F, and you can see now it's starting to make its way down the path. See? It kind of did that. It kind of said, hey, look, we're finding our way down the path, right? Okay, and let's remap it anywhere else and find the way. We can see that it's starting to find our way, but this is kind of weird. Look at this. It kind of mapped these ones as closed, and that's not what should have happened. This kind of path, this is definitely an error in our code. Okay, so move it and then map it, and now we've got a bit of an issue. And I knew this was going to happen because of our, we're trying to get tile state of something that doesn't exist, right? And the reason why this is happening is because of our, we never checked if the tile itself is not null pointer, right? So you can't return this if the tile is null pointer. If the tile is null pointer, it means that we're checking a neighbor that doesn't exist, right? So we're saying we're going to wrap all this in that. So if tile is not equal to null pointer, so that's our guard, and we want to wrap all of this. Yeah, I got my package. I want to wrap all of these things all the way to the bottom here. Cut it inside of this. So we're checking to see if this tile is not a null pointer. Yeah, okay, cool. So let's iterate. Let's try that again. So that's a fix. That was a bug fix that we didn't see because we haven't used this thing yet. Let's try that again. So back. So again, I'm going to press F or find a partial path. That was okay. Move it away. I'll press F, move a partial path. Right, move that away. Hey guys. Yeah, it does. We've changed it a little bit. And again, we're going to press, we're going to move it away. F, you can see that it's working now a little bit better. Right, partial path is working. That was weird, though. That was weird too. So look at what's doing here. So it's going, when it goes down here, somehow it's marking these as closed. And how is it doing that? Because it only supposed to be marking closed stuff that's undefined, right? And if it's already open, it shouldn't be marking those things as closed, right? So that should be, these should be open, open, open. So let's see, that's part of our get lowest cost tile thing. And guys, we're timing out, but you get the point. The point is that it's finding the tile slowly, and we'll fix this when we come back in a couple weeks. And we'll get to the point where it's going to work properly. But one thing to note is how this is working. So again, it's going through and it's saying, okay, if it's not the tile, return. And then it's going to say, okay, check the minimum value. Cool. And then it's going to set this. If min tile is not equal to null pointer, right, then it's going to set the tile to closed, and that can't be because it's got to be both null pointer and undefined. It can't be something that's already opened, right? I'm just trying to think of this, if this makes any sense. Because it selected it. If mid tile is not this, not the minimum tile, so it's going to flag it as closed because it's not null pointer. And if it's not already open, yeah. So this is kind of a little bit of a, some thoughts, right? So it's definitely got to be undefined for it to flag as closed, right? But then that means when we do our testing, which is this stuff. So let's say, for example, I check this one first. I make this 10 as an example, and then I set this as open, and then I check this one as an example, and that becomes 8. Then what I want is I want to go back up here and set this to closed. That's what I want to do. And then something like that, this logic that's happening here is setting the bottom ones to close for some reason or another. And it could be because the way that I'm setting up our previous tiles. So if it's already open, it's setting it to close, and it shouldn't do that going forward. So maybe we just leave it as open. And if we got rid of that, the minimum tile thing, if we just uncheck this one, I think that might fix us, although it'll cause other issues in a second. And then we'll be done for the day. Let's see. So 1. Oh yeah. And find. So we can see that that's pretty good. Finds a nice path, move it. Finds a nice path, move it. Finds a nice path. Okay, that is weird. That's definitely weird. Okay, well, again, we'll have to fix this one. But one of the things we want to try and do before we go, and maybe my good friend Josh can help me out here, because since he's my professor that's visiting now from yeah, I'm recording. Just keep that in mind. So if you're going to come into the field of view, here we go. Here's Josh. All right. Hi. So one thing that we can notice is, and sometimes it's good to have an extra pair of eyes, is what's happening is what I want to do is I want to loop through. Here's what I want to do, right? So as I loop through this, right now I'm only looping 5, but I want to loop through until I find my goal node, until the tile state is equal to the goal node, right? So the way it is I can say, instead of this, let's change this to a while loop. While tile, and then get tile state is not equal to goal, then keep doing, right? And what this does, unfortunately, is because tile will be equal to it, it will eventually equal to the goal, right? Because what's going to happen is it's going to find itself as a goal. And let's see if that's true. If it won't, it'll just loop forever, and we'll have an endless loop, and let's see how this works. So again, if I press F, yeah, now we're going to see it's an endless loop, see? It's going to keep going forever. And so it seems like I can't test for this state. You're my lucky charm. I know you can't. I know he can't debug things on the fly like this,
without even seeing the code.
Without seeing the code. But sometimes if he stands next to me, right?
That's the thing. It's called it's called rubber ducking. So
yeah.
I mean, it's possible maybe the heuristic isn't right, and
it's possible. Yeah, it's possible. It's possible in here. So somewhere in here is good. Anyways, guys, thanks, Josh. I appreciate that. My guest speaker here. on the Tom Show. And I will get back to this. I'll figure this out. And when we come back after the break, we'll talk about this. Remember, guys, for the people that are here, you have until Sunday night at midnight to finish off your test. If you don't, it's the goose egg. It's 0. Okay? I'll talk to you guys soon. Thanks so much.